In this session, we're going to look at some of the drainage tools available in InfraWorks 360. As you can see, I have a model already created. I'm going to open the bookmark menu and we'll select a bookmark to jump to my area of interest. Right here, I have an existing road and it has a culvert passing underneath it. That culvert is accommodating the flow of rainwater that comes down through this area. It flows along this stream, comes through the culvert, and then discharges into the river. Let's make the assumption that we are working on a culvert replacement project. I would like to use InfraWorks to calculate my preliminary watershed boundary. I'd like to calculate some preliminary flows, and then I'd like to use that information to help me place and size a new culvert. Let's rotate this up. To access the drainage tools, I'll open the drainage menu. I'm going to choose Create Watersheds, and then I'll click at the location of the current culvert. InfraWorks is then using the 3D DEM model to establish the boundaries for the watershed, the area that's tributary to this point. When it's finished, if I back up, we can see that it created a nice 3D representation of that watershed boundary. It also created some streamlines. If I select the watershed, over here on the palette we can see some statistical information. I can find the area, the channel length, channel slope, high and low elevation. We can use this watershed data to calculate peak flows for a 10-year, 50-year, and 100-year event. I'm going to make sure the edit mode is turned on. Let's change the hydrology method to rational. Using the rational method, I can enter a runoff coefficient. I'm just going to type 0.14 for this example, and then a rainfall intensity. We'll do 1 inch per hour. And when I press enter, InfraWorks 360 uses that data to calculate a preliminary 100-year flow. Let me drag this over. There are additional hydrology methods. I'm going to choose regression this time. Using regression, I can select my desired state. In this case, I'm working in New York. I can then choose my region. This area happens to be in Region 6. Then, based on my selections and the size of the drainage area, InfraWorks has calculated preliminary values for the 10-year, 50-year, and 100-year events. Now, let's use this information to place and size a new culvert. Before I place this, it's important to note that I'm working with a DEM surface. In order for our culvert to be as accurate as possible, we want to make sure that we're using survey-grade surface information and road centerline elevations in this area. That information can easily be collected out in the field and then brought back into InfraWorks. To create the culvert, I'm going to choose Add Culverts. After the culvert is placed, we can rotate around and take a look. If I select the culvert, it will bring up the culvert palette showing me statistical information about this culvert. Now, some of these items are collapsed just because of my screen size. We can see the culvert name. We can see some of the attributes with respect to length and invert information. Notice the culvert is being sized based on this watershed flow number. This is the 100-year event based on the watershed. If I select the watershed, we can see that value right here. Now, sometimes the culvert needs to be sized based on a 50-year event, or maybe even a 10-year event, or some event in between. If we wanted to do that, I can change my hydrology method to user-defined, and then I can place my desired peak flow here in the 100-year event. This just represents a number. This is the number that the culvert looks at to be sized. I'm going to type 200 as an example. Then I'll select my culvert. It'll take a second to process, but then it is resized based on that new number. Let's collapse the attributes. After the culvert is placed, I can change the number of barrels. As an example, we'll change this to 2. I can change its shape. The size is grayed out. That is based on the watershed calculation. That being said, if I wanted to size this manually for visualization purposes, I could do that by dragging some of these grips. I can also change its material, the Manning's value. I can change its shape. Let me fold this up. If I turn on the analysis results, I can back up and this will show me a nice schematic highlighting the headwater and tailwater elevation. I can see the water in the culvert during a peak flow. I can use this for analysis purposes. Likewise, if I click this icon down at the bottom of the palette, I can generate a report showing me much of this information. Now that I'm finished, I'll close this up and I'll turn off my analysis results. As you can see, using InfraWorks 360, you can quickly delineate watershed boundaries and establish preliminary flows. As your 3D model is further refined to include survey quality surface and roadway data, you can easily leverage that information to help place and size culverts.